All right, so when we solve this is going to stink. Well, actually, I can use this. So when we solve these systems by graphing, how do we determine where a line is? Like when we go to put a line on a graph, what two things are we looking for?
Y-intercept and slope.
Y-intercept and the slope. So if we want to look for the y-intercept and or the slope, which is which? Felipe, which is our y-intercept, which is our slope?
The y-intercept is the number without a variable, and slope is the variable.
So y-intercept is always going to be whatever the constant term is. So a constant term, remember, has no variable involved with it. So constant term is that -2. And the slope here then is always the m or whatever value is in front of your x. So the m is your slope. This is not working very well. Whoa. It's like dying at a certain point. Apparently I'll have to write above that imaginary line. And because I cannot graph on this thing, here is what this would look like as a graph. So we start our first one with a y-intercept of 2. And then what's the slope up here of this first equation? What is it? What is it? What is it? 1. Not 1x. The slope is just 1 because it's just the coefficient. So when I go to graph that, I start at 2. And I go over all this stuff in chapter 3. If this sounds a bit confusing, you got to do chapter 3 before you try to do chapter 4 on your own. And then our slope of 1, slope is just rise over run. So we go up by 1, over by 1, up by 1, over by 1. We can keep doing that. Then we graph my other line. So my y-intercept is -2. So I put my y-intercept at -2. My slope is 3. So now I go up 3 over 1, up 3 over 1, and we find the point where they cross. This is one easy method to find our solutions, is by graphing. When you put them both on the same graph, where they cross is your solution point. So that point of intersection is just 2, 4. So your solution for this equation is x equals 2, and it'll make both of these y's 4. Because think about it, if I plug in a 2 there, 2 plus 2 is 4. If I plug in a 2 there, 3 times 2 is 6, minus 2 gives me 4. And they work it out and check the math right there for you. Questions right now for what we just saw? Yeah?
Is this problem supposed to be part of the notes page?
No. So what should be on your notes page is this one. The 2x plus 4, x plus 2. You got that one? All right, go ahead and try that on your own. All right, so we know that the initial point you guys said is our y-intercept, and the growth is our slope. So here we have y equal to what? Who can tell me? Emily? 1.5x plus 4, because it's so x then represents months. And over here, who can tell me the equation for our other gator? Kenzie?
Y equals x plus 6.
Yeah, because it's just 1 pound per month, it'd be 1x, or we can just say x plus 6. So now we could put these both on a graph and find out where they will intersect. Now, can these guys go backwards in time? No, they can't go backwards in time, but could we look backwards in time? We could look, if we know that that growth rate has been constant, we could look backwards in time. Hopefully these guys intersect going forward in time. Anyone know a way that we can tell where they'll intersect, whether it's going forward or whether it's going backwards? Grant? Sorry, I can't hear you. Yeah, we already know the delta y, delta x, because that's our slope here. There's another way. You look at your y-intercepts. Kenzie, go.
So I think so the y-intercepts out there, 1 is less than that 1.
Yeah.
And the slope is more.
Yeah.
So that means that it gets bigger. It gets small at first, but it gets bigger faster, and that one gets bigger slower, so the road
Absolutely. I'm going to repeat it so I make sure it's on the video. So when our y-intercept is less and our slope is more, we know it will catch up. Because notice, this gator has a higher starting weight but grows slower. This gator has a lower starting weight but grows faster. So there will be an intersection point in the forward direction because gator 1 will catch up with gator 2. Leon?
We could also figure it out because.
All right, so what we do here, substitution is easier than really, I think, any other method. So here we're told y is equal to 3x. Now, what does that mean? This line, anyone really up on their math? This line has something but is missing something else, or not really missing, but we know something else. Raider? Has no y-intercept. So that means that this line is what kind of relationship? It's linear because it's in y equals mx plus b form, but it's also proportional because it has no, well, the y-intercept is 0 more so. Not that it doesn't have a y-intercept, but the y-intercept isn't shown because it's really just 0. So that's a proportional relationship, but that's really good for us because we can use that knowledge of knowing what y is to deal with this inequality, or this equation. Can I represent this equation just as x equals something? Ben, how would I do that?
We use substitution because you know y equals 3x.
Yeah.
So you put 3x in where the y is.
So if y equals 3x, I want to take that and I want to plug it in, so I can now say x plus 3x. That's a terrible 3. This pad, you guys will see as you watch my movies, this pad is weird to get used to. Because you're writing on a surface that you can't see what you're writing. So it's like, it's difficult. So then what do I do? Straddle. Okay, how? Lamp answer.
Well, first you're gonna add a symbol like
Blank blanks. Sophia, help them out. Combine like terms. So 1x plus 3x will give me 4x. And if that is equal to negative 32, now what do I do? Class? Divide by 4. Good, we're at least awake on that. What's negative 32 divided by 4? Ooh, good, you remembered the negative. So, am I done? A solution is looking for the x and the y. So if y is 3x, now I can set up, all right, y over here is now 3 times what I found as my x, which was negative 8. What's 3 times negative 8? Negative 24, which then makes my whole solution point. You want to write the solution as 1 point. So my solution is negative 8, negative 24. Substitution, you just take the one value, plug it into the other, solve it, and then plug it back into the original. All right, Felipe, what do I do?
You add 1 to each side on the bottom equation, so it becomes...
Wait, what do you mean? Add 1 to each side. I'm going to add and just get... What are you trying to isolate?
The x.
Okay, hey guys, let's focus in. So Philip is telling me I want to take this bottom equation and isolate the x. Now, why'd you choose the bottom equation?
Because it's a little simpler, and there's only 1 variable to sub in for 2 instead of 2 variables, or 2x to substitute in for 1.
Now, you're absolutely correct. Here's the thing. There's a bunch of right ways to solve this. If you think you're going to take a different way, I want you to quietly take that way right now and see if you get the same answer as us. So, Philip, talk me through what you're going to do.
So you isolate the x by adding 1 to each side. So it's x equals y plus 1. And then you substitute 2x for 2y plus 2.
So now I sub into this x right here. Sorry, again, the tablet's kind of hard to work with. So let's come over here and say, now I can say y is equal to 2 times y plus 1 plus 7. So now what do we do?
Then you would distribute the 2 to get y equals 2y plus 2. 2y from each side.
And now we have a negative y.
Equals 9.
So that really means y equals
Negative 9.
negative 9.
And then put the y in the equation which we used to substitute it in. So x now equals negative 9 plus 1.
Do not fall in the trap of negative numbers. What's negative 9 plus 1?
Negative 8.
Negative 8, because you're going in the positive. So now we get a solution of x equals negative 8, and y is negative 9. So our solution will be negative 8, negative 9. Now, does anyone think they have an easier way to solve that? Because that was a good method. That was perfect. Katie, what would you do?
So, well, I have a question.
Okay.
When you put the x plus, like in the green, it was like x.
Yeah, I can go back in the video. A y and a y, right? So I could just say, hey, this y, I'm going to replace u with this y. So now we could just set up an equation that is x minus 1, the y on the left side, equal to 2x plus 7, the y from the top equation. Does this make sense? So I took the y from the bottom and plugged it into the y on the top. Because you can substitute anything as long as you're following the mathematical rules. So now on both sides, we could just get rid of 1x, this x over here. Now I've got on the right side just x plus 7. So now I can get rid of that positive 7 by doing what? What do I do? Yeah, I put it on the other side through subtraction. And now I get x is equal to negative 8, right? Is that what I had before? Yeah. So then when I plug that x in to my first equation that I used to substitute, and actually I can plug it into either equation, but normally it's easier to plug it back into the first, I get y is equal to negative 8 minus 1, which actually gives me negative 9. And I still get that solution point of negative 8, negative 9. There are a lot of right ways to get to Florida, which means there are many correct ways to solve a math problem.